Hello and welcome to the final episode of my God of War tutorial series. Before we start today's episode, I just wanted to let you know that in the video description you will be able to find a download link to the complete project, which will also contain the logic added in this episode. So if you want to check that out, feel free to have a look at the video description. Today we will add some bonus features that were requested during the course of the series, and later I'll show you how easily you can migrate your radar system onto a different UE4 project. And for that we will take the first person template as an example. Let's start with a little bug that I want to show you. If we hit play here and don't do anything, you will see that currently north and south are overlapping on our radar. And if we move our mouse around, we're not turning around. For that to happen, we need to click in here once, so it reads our input. That is a bug that we can very easily fix. If we head over to the third person character and open up the blueprint editor, on event begin play, after we initialize the radar, we will drag off of the radar again and call on become visible, which updates all of our markers and so on. If we compile, save and then hit play, you will see that the bug is fixed. Now north and south are positioned properly when starting the game. To make your game immediately read the input without having to click in it once, the node that you want to use is called set input mode game only, and do that on event begin play in any class. Then it will be asking you for the player controller, and to get this we simply call get player controller at index 0. If we compile, save and play now, I don't have to do anything. I'm directly in playing mode and can turn around to make our radar update. So that's it for fixing this bug. One feature that was requested in the comments is that when we turn around, the objective markers are currently being hidden when they're out of sight. However, in God of War, sometimes they will stay at the very edge of our radar, even though they're out of sight, just to indicate that there is something in that direction. So let's make that an option for our radar component. Let's open up the components folder and BPC radar component. Then in here, to make it an option, we will add one variable of type boolean, and we will call that hide out of sight markers ? So that will be something like a configuration of our radar component. So for category, let's put that into configuration. We'll make it editable and exposed on spawn. Then compile and save, and the default value of that is true. So by default, we are hiding markers that are out of sight. To make this boolean have an actual influence on the logic, we will go into our update marker positions function, this one here. So that is responsible of where our markers are on the radars. Let's add a little bit of room, because before we do anything on the loop body, let's drag in the variable we created, hide out of sight markers, and off of it let's add a branch. Hook it up to the loop body. By default it's true, and that would be the functionality that we've got so far, so we'll just go into the other branch. If not, means we don't want to hide them but stay at the very edge of the radar. So in that case we don't need to set visibility, we only want to set the render translation. Let's copy and paste that for false, with the target being the array element. And then we have to figure out that translation. So let's use a select node and hook up the inRadar side as the index. So if it's true, we don't have to make our markers stay at the edge, so we can simply take the translation from our rotations to translation node, plug that in for true. If it's false, however, means we have to make them stay at the edge. And for that we will make a vector 2D, then you've got x and y. We're not using y, only x. And for x we need another select node, select float, and hook up the clockwise as the pick A. Because based on whether clockwise or anti-clockwise is closer to the marker, we either have to take the maximum widget translation or the negative value of that. So if it is clockwise, means it would be A, then we simply take the maximum widget translation and plug that in for A. And for B, we simply multiply that by an integer, and that would be -1. Then hook that up to B. Alright, compile and save. So that's it already for the logic. However, our hide out of sight markers is true by default. So let's close our radar component and open up the third person character. Then select its radar component, and we will uncheck hide out of sight markers. Alright, now I'm back in play mode. We see our two default quest markers for the main and sub quest, and if I turn around, you see that the main quest now stays at the edge and is not hidden, and the same would go for the side quest. It would stay at the other edge until we're facing the correct direction again. We only applied that logic to the quest markers. You can do the very same thing, for example, for the landmarks or monsters if you want. However, I think it makes most sense to use that only for quest markers. Otherwise, your radar will just be full of elements overlapping each other. Another requested feature was to show the relative elevation to a goal location. So if the goal is on a higher spot than our player, we will indicate that with an arrow facing upwards. And if it's below the character, there would be an arrow facing downwards. You can also see this feature in God of War, I think. And that somewhat makes up for the fact that when we're calculating distances to a goal, we're taking out the z, so the altitude of that goal. And just to give our player a little bit of more information, we will use that arrow. So if we have a look at our textures folder, I already imported a texture that is called elevation arrow. In the video description, you'll find a link to Imgur where you can download that single texture and import it yourself. We'll open it up and set the compression to user interface and texture group to UI. Then we will save it. And we want to integrate that into our quest marker widget. So for every quest marker, we will show the relative elevation. Go to widgets and to the W_marker. Right now, the size of this widget is defined by the size box here, and it exactly fits the size of the text element and the icon. So we've got to increase that. We'll just set the height to 68. Then we will add a spacer to the vertical box and enter a Y of 2. So there will be an empty space of 2 pixels, and then we will add another size box to our vertical box, make that align center and center in both dimensions, then hit width and height override and enter the dimensions of the texture here. So these are 28 pixels in width and 18 in height. Then grab an image and drag that onto your size box. Let's call it the arrow image. And for the brush image, we will select our elevation arrow. By default, it's facing upwards. If we would want it to face downwards, you can go to scale and just for Y enter -1. So that will mirror it on the Y axis and therefore it will look downwards. But let's reset that to 1. To make that arrow a little bit less obvious, we will select the size box and set the render opacity to 0.8. So just that it is a little bit more subtle. Another feature I want to add here is that the color of this elevation arrow matches the one of our marker icon, so based on whether it's a main or a side quest. To do that, we can just go to color and opacity and pick 2 colors. So I'll look for something like an orange here for main quest and drag and drop that onto our palette so we can reference this later. Then I'll remove the other ones. Select your W marker and type side quest so you get the other marker icon. Now we'll look for a blue color that matches that, so something like that, and also drag and drop that onto our palette, hit OK. After that we can reset the color and opacity here to white, and select our marker again, type will be main quest, compile and save. Then we'll head over to the event graph, and if we go to the event pre-construct, we are currently only setting the marker icon. Let's grab our arrow image and set color and opacity. And this one will depend on the type, so select and hook up the return value to in color and opacity. Then double click your main quest and there we will select the orange of our palette. Then we'll go to side quest and choose the blue here. You can already see that updating in real time if we head over to the designer. See currently it's orange for main quest, and if we select side quest here, changes to blue. So that's already working. The other thing is that we need a function to set the direction of that arrow. I just showed you that you can do this using the scale in Y to mirror it. So we will call this function setArrowDirection and give it one input of type boolean that we will call up ? So upwards is our default direction. Let's expand the input here and make that default value true. So by default it should face upwards. Then grab your arrow image and set render scale. Split the scale because we only worry about Y. For X enter 1. And then based on our up input we will select a float. Hook that up to the scale Y, and if it's true, so A would be simply 1 and B would be -1. That's already everything for setting the direction of that arrow. If we have a look at the designer again, you saw that the total size of our widget here has changed. And that means that we have to go to our radar widget. If we quickly have a look at our marker and add that to an overlay, if we set it to center now, you will see that it's not perfectly aligned. So what we need is a padding to the top of, let's say, 5 pixels so that it fits. Keep this number in mind. We need a padding of 5 pixels to the top. Remove the marker here and we will go to our add marker function. So right here, we are currently setting the padding to 4 bottom. That is no longer accurate. It will be 0 to bottom now and 5 to top. Compile and save. Right, that's it for widgets that are related to this elevation arrow. We still need to script the functionality. So let's go to our components and BPC radar component. First off, we need one variable here, which we will call the default elevation range and make that a float. Instance editable, exposed on spawn, in our configurations category. Then we will compile, save, and give it a default of 150. Let me quickly explain this variable. So when we compare the position in Z of our goal to the one of our player, just because it's higher or lower, we don't always want to show the arrow. Instead, we will use the default elevation range of 150. So basically that means if the Z of our goal is in a range of the player Z minus 150 to the player Z plus 150, we will just say that it's approximately the elevation of our player and then don't show our arrow at all. And only if it's below that or above that, we will show the arrow. Let's add a function here called update marker elevations. And we want to grab our radar widget, then grab all of the marker widgets and run it for each loop. Hook it up to the function, and once it's completed, we can return. Now we need to check for the player Z and goal Z. So first off, let's get our markers, quest markers. Then we will get from that at the array index. So this here will be the marker that we're currently dealing with. Let's break it. We don't need the type, so we can hide that. And also break the location, because now we're only worrying about the Z. X and Y are not important for us. And we will check whether that Z here is greater than a float, and we will compare it to the player Z. So under player and camera, get your player reference. Then grab the actor location and also break that. So you've got X, Y, and Z. But like I said, that is where our default elevation range comes in place. We will get the Z and add a float, and that will be the default elevation range. Then hook it up to comparison here and add a branch. So if our goal Z is higher than the player Z plus default elevation range, we know that we need to get the array element here and set the arrow direction, because now we know that the goal is at a higher spot than our player. So we make our arrow face upwards and then also show that arrow. So off of the array element, get the arrow image and set the visibility to self-hit test. If it's false, we also have to check whether the Z of the goal is lower than the player Z minus the default elevation range. So let's look for a less than, and off of our Z here from our player, we will subtract default elevation range and hook that up to the comparison. Then add another branch and connect that to the false of the first branch. So if that is true, we will also set arrow direction and visibility, but this time to downwards. So uncheck up and connect the array element as the target, then the arrow image as the target for the set visibility node. And if both of these branches are false, means that our Z is in the elevation range of our player Z. So in that case, we will simply set visibility to hidden and also connect the arrow image. Save. Of course, we also need to call this update function here. So let's head over to the event graph and first off to our onBecomeVisible event. So in here, we will update marker elevations, and that can also change when our player moves. So at the very end here, also update marker elevations. Don't have to worry about turning because that doesn't change the Z of our player. Compile and save. And if we were to play now, you can actually see an up arrow for our side quest, because I think we placed that somewhere here. Yep, now that we've moved onto the staircase here, the arrow has gone away. And you now see an arrow facing downwards for the side quest, because if we jump down here, that should be somewhere on the ground level of our level. Alright, so these arrows are also working perfectly. Now that all features are in place, I will show you how easily you can migrate this system onto other UE4 projects. So in the library of your UE4 launcher, we will launch the engine and wait till it's running. And we want to create the project that we want to migrate our radar system to. So let's go to new project and we will select the first person template with no starter content and just call that radar migration. Then hit create project and wait till it's loaded up. Alright, so that is the first person project that we just created. Let's switch back to our project that contains the radar system. And one thing that is very important to keep in mind when migrating is that you should try to keep all of the assets related to that system in one folder. So in our case, that would be the radar system folder. However, we are still using assets that are not within this folder. For example, for our enemy, we are using the third person character mesh and animations. These are currently in the mannequin folder. So we simply grab the mannequin and move that onto the radar system and then hit move here. Alright, the other thing is that for our secret objects, we are using a static mesh with the default of the 1 meter cube. And that can be found in the geometry meshes. So the 1 meter cube is here. That is also part of the system. So let's grab geometry, move that onto radar system and hit move here. Alright, now everything is in our radar system folder. The only things left are the third person template meshes that are used for the level here, and the map and third person character and game mode, so we don't need these. Once you've got everything in your separate folder, right click that folder and hit migrate. It will ask you to save the content, so we'll just hit save selected. And you will get a list of all of the assets that will be migrated, so you can just quickly check whether everything is included here. Looks good. So simply hit OK. And then you have to choose a destination content folder. So this is the place where you will migrate to your other project. In my case, that is the radar migration folder. Then simply select the content folder and hit choose folder or select folder. Here it reads an asset already exists at location, so the 1 meter cube. Let's say we just want to override that and import our own cube. It will read copied 50 files, so that's good for us. Let's switch to our other project. Back in our first person template, we now got a folder called radar system with all of the assets in there, hopefully. Let's have a quick look. We only have to make very few changes here to make our system work. So let's go into our first person character and we want to give this guy his own radar. So add a component, BPC radar component will show up, and let's rename that to the player radar or first person radar, doesn't really matter. Then let's look for event begin play, and unfortunately there is a lot of VR stuff in here that we just want to ignore. So we will add our logic before that. And here we just have to add the nodes that I showed you in the third person template. So set input mode, game only. And for the player controller, get player controller. Then after that, grab our player radar and call the initialize radar event. Now it comes in handy that we made the player and camera inputs very generic. So the player here should just be an actor, which means we can hook up self. And for the camera, let's look for the first person camera here. Drag that in and hook it up. Then after we've initialized it, off of the player radar, call on become visible. And after that, I'll just go into the branch of the HMD stuff here. We were using the C key for visibility, so let's look for that C key. And we will grab our radar again and toggle visibility. Let's check animate for that. And the only two things that are missing are our onPlayer moved and onPlayer turned event. So let's look somewhere here, the mouse input axis turn. We'll grab the axis value and check whether that is not equal to 0 and add a branch. If it's the case, grab your player radar and call onPlayer turned. Then let's look for the movement input. So that should be input axis move forward and move right. Again, let's grab a not equal float node, check for not equal 0, add a branch, hook it up, and if it's true, grab your player radar and call onPlayer moved. Hook it up to true. You need the same thing for move right, so let's copy our branch and the not equal and paste it, and then simply hook up the access value. Compile and save, and that was all of the logic you had to do to migrate the whole system. Now we can just close the first person character and add some stuff in here. So let's go to classes and we'll add a master landmark, maybe let's say back here, and let's say this here is the tower. Then we'll grab another landmark and let's say we will place it here and select the city, so landmark underscore town. We'll grab our master monster and move one here. Remember, for your monster to move you need a nav mesh, so let's just quickly check whether there already is one in here. No, it isn't. So let's use a nav mesh bounce volume and drag it in here. Let's move it down somewhere in the middle and scale it up by, let's say, 20. If we then hit P, yep, we see that everything is covered, so that's good. You move it a bit to the back. Yep, that looks fine. We've got our monster and landmarks in place. Let's add a secret here, and we will just increase the highlight radius by a bit. Then we're missing some basic goal locations, so let's add a target point somewhere in our world. Maybe let's say back here, and copy the location, go to our player, and for our radar we will go to the default quest markers and paste the location for the main quest. So we just set up some testing elements, and if we hit play, I'm now in play mode. You see that north, east, south and west are already working properly. Then we've got our quest marker with the elevation pointing us upwards, because it's somewhere placed on the box here. So if I jump, you see that that went away. We've got the landmark tower here and the landmark town, which is somewhere here. We've got the secret object here, and if we move in there, everything is highlighted. We can press C to hide our radar and press C again to show it. And finally, we've got our enemy, so if we approach that, you see the marker appearing 2 meters away, and that also updates when we turn around, when we move, or when the enemy AI moves. Alright, you see that the migration is extremely easy. That is because of 2 aspects. We set up everything in a component, which is very easy to migrate, and we never casted anything to specific player classes, for example the third person character, but just use actor references. Or in the master secret, for example, we don't care about the actor at all and just check whether that one owns a radar component. So this will also work in whatever template you're using, given the fact that your player there has a radar component. So that is the end of this episode and of the whole radar system series. I hope you liked it. Please tell me about that in the comments, and don't forget the download link in the video description, and see you in the next series.